In this example, we are asked to graph a piecewise function. To do this, please do not use your calculator, but you might want to pull out a piece of graph paper. These functions must be graphed precisely and accurately, and so the graph paper will help us do this. For this particular example, notice that each of the three pieces that are in my piecewise function are linear, meaning that this, if it was graphed by itself, could be written as y equals, the slope would be 1 over 1 x, the y-intercept would be 1. This one, if it was graphed by itself, would be y equals -3, which would be a horizontal line. And then this one, if it was graphed by itself, would be y equals slope of 1/3, and then because it has no constant value at the end, y-intercept would be 0. Now, the way that I'm going to do this is not pretty, but it's the best way that I know to explain based on information that you already know. What we will do is we're going to graph each piece by hand and make sure to work towards what I'm going to call our cutoff values. The cutoff values are going to come from the x's that we have in our inequalities. In other words, the first graph is only good for x's less than or equal to -5. This graph is only good for x's between -5 and 6. And then the last one's only good for x's greater than or equal to 6. So our cutoff values are going to be -5 and 6. So we're going to work towards those cutoff values as we graph each piece, and then what we will do is we will erase the parts that we don't need for each graph. Also, being careful that we either use closed endpoints or open endpoints depending on which piece we're working on. So first, I will go and work on the first function. So if I were going to graph y equals 1 over 1x plus 1, I know the y-intercept is 1, and then the slope is 1, so I'd go up 1 over 1. What I will do is I will continue to do that in the direction that would take me towards -5. So actually in this case, doing that, I could think of my slope as -1 over -1 so that I could work my way to the left. So I would go down 1, left 1, down 1, left 1, down 1, left 1, until you arrive at -5. Now, what you also need to do is you probably need to go past that -5. So if I go down 1, left 1 more, this is where I would arrive. Now, if you were to graph that entire function, your function is going to look something like this. And please pardon, I know my line's not super straight, but it's meant to be a straight line. And so that would be the graph of that function. Now, here's what I mean by get rid of what you don't need. This function is only good for x's less than or equal to -5. So on your x-axis, you want to go to -5 and say this function is actually only good for x's less than or equal to that number. And so because it's equal, you would have a solid dot at the -5, and then the only piece of your function you would want would be the part going to the left. So now we'll come back and we will erase the rest of that function that we drew. So the reason I do it this way is because you know how to graph y equals 1 over 1x plus 1. So I'll first ask you to do that, keeping in mind that you want to go to that cutoff value of -5. Once you've done that, then it's easy to erase the part that you don't need. Notice that we did a closed dot at the -5 because there was a bar underneath my inequality from up here. So because of this bar, then I used a solid dot down here to say that's included. Now, we've got this piece. Now go down to the middle piece. This piece is y equals -3, so that's going to be constant. On there, we know that y equals -3 is a horizontal line, and so we would have a horizontal line going through -3. So that would be our entire line. That one is only good when our x's are between -5 and 6. So I'm going to identify, here's -5, here's 6. Well, it's only good between those values. And we also see it's not good at the endpoints. In other words, neither endpoint is included. So we want to use an open circle here and an open circle there, and then get rid of the things to the left and to the right. So that would be the graph of my line here. And I'm going to change those endpoints just a little bit to make it perfectly clear that those are not included. So don't include that, don't include that, and then we have everything in between those. So now we have that middle piece taken care of. From here, we will now go and do the last piece. The last piece, we see we have a y-intercept of 0 and a slope of 1/3. So y-intercept of 0 would put us here. Slope of 1/3 means you're going to go up 1 and over 3. So up 1 and over 3 would put me here. We're going to do this until we get to the endpoint of 6. So up 1 over 3, I think that puts us at 6. We're going to do it one more time to get beyond 6. So up 1 over 3 put us here. And then if we were going to graph that line, it would look something like unto this. Okay, now, for this line, we want to look and see what it's good for. It's only good for x's greater than or equal to 6. Where is 6? 6 is right here. So if it's only good for x is bigger than 6 or equal to 6, then we'd want to have a closed endpoint there, and we would only have the right-hand side of this graph. So from there, I would come back, erase this part that I don't need. Now, online, I would recommend that you do this by hand first. Once you have it done by hand, transfer what you have on your paper to the online portion so that you're able to create your pieces. They will have points that will either be open points or closed points that you can create your lines with.